Hello, welcome to this video on LTM4659 demo board. The LTM4659 is a tiny 2.25 to 5.5 volt ultra low EMI noise silent switcher to DC micro module. In this video, we will set up DC32488 demo board to take the transient measurement. Let's set up the demo board to take some measurements. We are going to verify how LTM4659 current mode architecture enable a fast transient response to line and load changes without sacrificing stability. To make things easy, this board has a built-in feature to measure the load transient. Evaluation board has load transient circuitry with external FET Q1 and sense resistor RS1. We are using the same circuitry without any changes in the compensation components. We need function generator to turn on and off the FET. Using function generator, we will provide 2.5 amps of step load with the pulse width of 28 microseconds at IO step clock and ground using BNC to clip cable. For function generator setting, keep the pulse width short less than 1 millisecond and pulse duty cycle low less than 5% to limit the thermal stress on low transient circuit. When we provide the IO step clock signal to FET, it will turn on the FET and we can measure 50 millivolts of voltage drop at IO step across RS1, and when we remove the clock signal, it turns off the FET and we get 0 volt at IO step. Now we need to connect the power supply to the input of the board. The board has an input voltage range from 2.25 to 5.5 volt, but we will set the input voltage to 3.3 volt. I will also make sure that the current limit is high enough so that we do not current limit the output. This test is performed at no load 0 amp condition. This board can output 1 volt. Now we will set up the scope screen. Here I am connecting 10x probe for channel 1 to connect IO step clock, BNC to BNC for both channel 2 and channel 3, channel 2 to IO step and channel 3 to Vout. I am providing trigger to IO step clock in normal mode and AC coupling to channel 3, and arrange the oscilloscope setting as shown on the screen. Now I will enable the power supply. I will turn on the multimeter and make sure that the output voltage is 1 volt. Now I will turn on the function generator output and provide IO step clock signal. This way we can replicate the transient response of LTM4659 as shown in the figure 6 of the user guide. We can see that when we apply the IO step clock signal, the FET will turn on and output voltage will dip. When the IO step clock signal is removed, the FET is turned off and voltage output will go up. We can see 50 millivolts of IO step signal which replicates 2.5 amps of load step. That's wrap up the bench measurement. You will find LTM4659 idle for telecom, datacom, optical module and point of load regulation and industrial equipment and daughter cards that has a limited input voltages. For more detailed instruction and information, please refer to LTM4659 product page, which contains links of simulation models such as LT-Spice, the datasheet, demo boards and its user guide. If you have any further questions or require any technical assistance, feel free to reach out to technical support at the link given below or ask a question button on LTM4659 product page. Thank you for watching.